All right, guys. I hope you're doing well today. I tried to pick something that was interesting to me in my field of study and what I teach is biology. So I was looking for something in that vein of, biology. So I found this frog um, data that was based on the altitude that you would find the frogs in the Tibetan mountain plateau. So we're going to look at a couple things: clutch size, egg size, clutch volume. Also, like how does that relate to potentially overall fitness? Now, fitness in evolutionary biology is really what we refer to as the ability to have a baby that could have a baby. That is fitness. So it's not thinking about like, it can run away from predators fast or things like that. It's really just about its ability to have babies that could have babies. So, research questions. Does altitude predict reproductive investment? So, reproductive investment in this case is referring to egg size, clutch size, and volume size. And so, how does that look in these high altitude populations for these frogs? So, really, what we're looking at is how does the altitude affect the clutch size, the volume size, and the egg size? So, it's going to be kind of three different. With the data that I was given, I think this is the best way to kind of look at this research question is in three different parts. So, the source data, we have 431 observations. Something I want to draw a little bit of attention to is down here at the bottom. Unfortunately, they were only able to get 130 individuals, the female's body size. So, with that being said, as opposed to only doing 130 data points or, individuals, what I did is I removed, or I did not really look into how does the body size affect any of these other things because we're missing almost 300 data points. So things we saw in the data: altitude, where it was and how many meters above the sea. This is kind of how I put it into R when I was running it, labeling these things. Latitude, once again, latitude really wasn't talked about or didn't seem to be when looking at that, it didn't really seem to be a factor in any way, shape, form, or fashion. So I just kind of didn't really worry about that because there was very clustered, and we'll see on the altitude is clustered as well. Here's where we really get to estimated number of eggs. So that would be the clutch size. Once again, we talked about the length of the mother and the size of the mother. It would have been interesting if they had, 431 of those, but they did not, unfortunately. Volume of the entire egg clutch. So frogs kind of lay them in, many amphibians lay them in like little bunches. So it's almost like a little ball. So they measured that as well. And then the average egg diameter, measured that all the way down to 0.01 millimeter. So once again, 431 clutches across 11 different sites. Here's the range in meters, pretty high up. The predictor variable, or that's what we thought the predictor variable would be altitude. And then the outcome, egg size, clutch size, and clutch volume. All these are continuous, and I'll talk about that a little bit in the next slide and what I chose and why I chose to do it like that. And once again, there was that weird subset where we had 130 with the female body size, but that leaves off 300 approximately that do not have that. So we really didn't delve into that part of it. So what I did is simple linear regression. I guess in hindsight, it would have been cool to have some cooler looking, visuals for this. But we can see that the frogs kind of cluster here at different altitudes. And with this we have egg size at approximately 2,000 feet, all the way up from, almost a millimeter apart in size, which is, fairly significant and different in size. But you see, there's no real, we can look at these lines as well. All right. There's really no predictors here. I think in hindsight, I'll talk about this a little bit later, but maybe with more understanding of stats, I could have looked at the data and found a better way to run this. But with what we've done and what I've kind of understood, I think this was the best way to run it. Fits, like I said, they're both continuous, so we kind of have to have this continuous predictor. Now, when we look at the statistics, the non-visual statistics of it, we can see that slopes, t-values, and p-values are all these are kind of high, honestly. All right. And even if we did have a low or low-ish p-value, our r squared values are very, very close to zero. So even if we had something that did have an effect, something that was statistically significant, the effect would have been, almost negligible, right? And so, I mean, unfortunately, we didn't really find anything here. We would have to reject or accept the null hypothesis, or fail to reject, technically, is what we should say. And so there is no statistical difference from what we can see, but that not having statistically significant data doesn't mean that, this was all for naught. So, if they're going back and kind of thinking about how they want to redo this study, how they want to look at it, they might try to clump them a little bit better. They might try to really find something that a better predictor, or maybe even get all the body sizes and see if altitude or body size is a good predictor for like where the female frogs allocate their energy, either making bigger eggs, making larger clutches, or making total clutch volume a little bit bigger. So I kind of talked about it right here. I didn't find any significance in any of the data, but that doesn't mean it's not there. Maybe a more sophisticated model. I know sometimes you can use like logarithmic functions and things like that. I'm just not that good with this. So this is kind of what, the approach I took. So I really wanted, like I said, overall thoughts, I really wanted to use a data set that I thought it would be interesting to me. And this was, I found it cool. But unfortunately, it didn't add to like, beautiful graphs or things like that. That's okay. What we saw, or what the data I ran showed, there was no significance. So that doesn't mean that it wasn't good research. It just means that maybe there's something else that we're not seeing. Okay. Thank you very much. Hope you'll have a great day.